So we are basically still under electrolysis of aqueous solution, and the last point that we'll discuss was electrolysis of concentrated sodium chloride and electrolysis of dilute sodium chloride. We actually arrived at the fact that when the solution is concentrated, the halide at the anode will be given preferential treatment, but when the solution is dilute, okay, normal course will follow. Hydroxide would be preferentially discharged at the anode, but at the cathode, each time your hydrogen will always be discharged, because hydrogen is lower than sodium in the reactivity series. So let me just take you through a few illustration. Okay, so this is called Hoffman's apparatus. This apparatus is called Hoffman's apparatus. So here basically you pour in your solution that you want to electrolyze into this plate, and of course you can see the positive electrode, which is the what, the excuse me, anode, and the negative electrode, which is the what, which is the cathode. So this solution here is a solution of sodium chloride, concentrated sodium chloride, which is called brine. So electrolysis of brine is also electrolysis of concentrated sodium chloride. So in here you would expect that migration will begin to take place, and of course migration will take place at the cathode. You have the positive ions in your sodium chloride migrating towards the cathode, while at the anode the negative ions will migrate towards the anode. In case you have forgotten, in the sodium chloride we have sodium plus, hydrogen plus, we have chloride minus, and hydroxide minus. Okay, so in this case now, hydrogen, okay, will be preferentially discharged, and chloride will be preferentially discharged, because chloride is more in concentration, not because it's higher, it's more in concentration than hydroxide ion. So because chloride has home advantage, it's going to be preferentially discharged, but hydrogen will be preferentially discharged because hydrogen is lower than sodium, so it will be given preferential treatment. So here at the cathode you have your sodium and hydrogen migrating. So hydrogen comes here. When hydrogen gets to the cathode, hydrogen will be discharged as hydrogen gas. Here it will be collected here, and chlorine or chloride ion, when it gets to the anode, it will be discharged by losing electron to form chlorine gas. Okay, so usually the chlorine gas is collected into this particular tube for testing, and also hydrogen gas will be collected here for testing, and we could also collect a sample of this remaining liquid so that we can test the three of them and see what we can make out of the electrolysis. So you have your chlorine gas being collected, okay, here, and your hydrogen gas being collected here, and this sample of the remaining electrolyte is taken by using a pipette, and of course through the pipette it is put into the test tube. So the next thing is just to test the three substances in the test tube and see what they are. Okay, so test for chlorine, you need to know that chlorine actually, okay, if you dip damp litmus paper into a container containing chlorine gas, so what's going to happen ultimately is that particular litmus paper will be bleached. You can see the color being bleached, becomes decolorized, so to say. Okay, it's being bleached, it becomes whitened, okay, or off-white color. So that's the test for chlorine. If we dip litmus paper, red litmus paper, into chlorine gas, it's going to bleach it. If we dip blue litmus paper, it's going to turn it reddish. Then reddish is going to turn it, it's going to bleach it. So the color will fade and becomes something of white. Okay, you are also expected to know the test for hydrogen. How do you test for hydrogen? You introduce a lighter splint into a container containing hydrogen, and when you hear a squeaky pop sound, that tells you that the gas in here is hydrogen gas. Okay, so let's look at a few more examples of electrolysis. Let's look at electrolysis of maybe sulfuric acid. Okay, so this is just an illustration of what takes place during electrolysis. At the positive electrode, you can see what's going on at the positive electrode. The chlorine migrating to the positive electrode, okay, because unlike charges what attract, and when they get there, they lose electron and become discharged as what chlorine molecule. The same thing at the negative electrode, you have your hydrogen migrating to the negative wall, to the negative electrode. They migrate here to the negative electrode, so you can see what's taking place here. Unlike charges what attracting, so the hydrogen goes there to what, to receive electron, and of course becomes what, discharge as hydrogen. So that's why at the cathode, okay, at the cathode you have reduction taking place. Remember crow. Okay, so let's look at electrolysis of sulfuric acid, and just use it to wrap up the idea of electrolysis in aqueous solution. Now for sulfuric acid, I'm going to be splitting it into the respective ion too. Sulfuric acid in solution H2SO4, okay, can be broken down into two, okay, hydrogen ion and sulfate ion. Okay, so this is your positive ion, okay, while this is your negative what, negative ion. Okay, this is your cation ion, while this is your anion. So start getting used to the terms. Now also, because it is aqueous, you know water molecule will be present. So water molecule 2 can split into hydrogen ion and what, hydroxide ion. So basically, just like we did before, you have here the positive ion, and of course you have here the negative what, the negative ion. So what's going to take place here? Luckily for the positive ions, they are of the same tribe, hydrogen, hydrogen. So there's no competition. So this migrates towards, where will it migrate to? Cathode or anode? Cat ions are ions that belongs to the cathode. So this migrates towards the cathode, and your cathode is a negative electrode. Okay, your anion will migrate towards the what? Towards the anode. To migrate towards the anode. Okay, anion is a positive what, electrode. Unlike charges what, attract. So when hydrogen gets towards the cathode, what will happen to hydrogen? Hydrogen will do what? Lose or gain electron. Remember crow. Cathode is reduction, and of course reduction is gain. Okay, so hydrogen goes there to gain electron. H plus, okay, will go there, since they are, okay, will gain one electron to form hydrogen atom. Because hydrogen gas is diatomic, so we'll make that 2, multiply this by 2, multiply this by 2. The concept is just simple. Okay, so hydrogen gas will be discharged at the what, at the cathode. Okay, so at the anode, now you have 2. The 2 of them are not the same. Okay, so which one will be preferentially discharged? Remember I showed you a list earlier. Remember here, okay, sulfate, look at the position of sulfate and hydroxide. Sulfate is higher than hydroxide, so which one will be given preferential treatment? If you were the one distributing the ice cream, will you give to the stronger person or to the lesser? You give to the lesser person. So hydroxide will be preferentially discharged here, giving preferential discharge. So your hydroxide comes in to the anode, and anything that comes to the anode is coming to lose electron. So it's going to lose one electron, and of course the product of this reaction, it's a bit complex. It's going to form water and oxygen. So because oxygen is diatomic, we have 2, so everything here has to be multiplied by 2. Okay, so basically, how do we balance this equation? I have 4 hydrogen here, 4 hydrogen on this side. So what can I do? I multiply this by 4. If I multiply this by 4, I have 4 hydrogen, and my oxygen too is 4, balance. So but if one of these, okay, lost 1 electron, 4 will lose 4 electron. So you can see the equation at the anode and what at the cathode. So you need to know by heart that each time your hydroxide is discharged, okay, it's usually going to lose 4 electrons to form 2 water and 1 oxygen. So let's say it together. 4 hydroxide will lose 4 electrons to form 2 water and 1 oxygen. 4 hydroxide losing 4 electrons to form 2 water and 1 oxygen. 4 hydroxide will lose 4 electrons to form 2 water and 1 oxygen. So you can see that at the anode and at the cathode, we have half equations, half reaction taking place: reduction, oxidation. Reduction at the cathode, oxidation at the anode. Reduction at the cathode, oxidation at the what? At the anode. And that forms your electrolysis. So ultimately, we have the product here is hydrogen and what? And oxygen. So you usually will have questions like this to solve, where you'll be asked to predict the product at the cathode and what? And at the anode. So you may want to just practice, go through your textbook, watch the video again and again, and you'll be able to carry out this activity. Okay, just a little hint here for you. Copper is metal, this is non-metal. So you would expect that if copper is metal, it's positively charged, metals form positive ion, chloride forms negative ion. So like charges attract, unlike charges repel. So basically, straightforward, you can your copper will migrate to the what? To the negative. That's all. So that's how to solve it. Okay, I will see you in the next video, where we are going to be discussing about the uses of electrolysis.